I think I've invited Robert to speak.
And Craig and Giark have deigned. Now that I've given them, I've succumbed to their demands.
Listen, the podcast starts when Craig and Giark says it starts. I also do love this is where you're getting a little bit of a Tomax and Zaymont thing, and that they you would think you might have some redundancy with the twins here, but they actually apparently think with a like mind.
So they share at least a like set of permissions in Discord.
Listen, Tomac and Zaymont had shared the pain. These guys share permissions. It's a little,
makes more sense. It's a little less. It makes more fantastical.
It's a little more pedestrian, a little more quotidian. But come on, I mean, this is just it's just trying to be realistic over here.
There you go.
Robert, you're here.
Yeah. Good evening.
Excellent. How are you? You know, our former colleague Alex Wilson said, it is really great to see you kicking off Robert Mustacchi Appreciation Week this way.
That's funny. I got a very different sounding message from him.
Well, I don't know if you quite ate the hook the way I did, but I was just like, oh, is that a thing we do? Is that like an annual thing? Because we have our colleague CJ has kicks off, and there is an Eric Anderson Appreciation Day here at Oxide for one of our employees. So seems like a reasonable thing that we would do to have a Robert Mustacchi Appreciation Week. I don't know, have we, so after I can't quite tell if he's joking or not. So I did ask him, is that like a thing? Have we done that? He's like, oh yeah, it's definitely a thing. It's documented in rm.c, and it's actually an extraordinary block comment complete with diagrams. And I'm like, okay, where's this? I've clearly missed something. I'm like, have I missed a annual celebration that we do about? And then my mind's going to super weird places. Have I always been out for Robert Mustacchi Appreciation Week? Is that a source of resentment that Robert? I mean, I just don't know. I'm just and where is rm.c? And so I went to some pretty obscure places looking for this thing, and I can't find it. And I'm looking at by the way, I do not recommend looking some of these rm.c. I mean, and Robert, I guess this is the curse of having a name that is an old Unix command, but hey, I've got BMC over here, Base Port Management Controller. It's not good over here.
Yeah,
I don't know if you've ever been in rm.c.
I have a little bit.
It is not a track. Yeah, it is really not a good looking file, but I can't find this thing. And so finally, after a half an hour, I'm like, okay, look, I'm gonna have to ask the embarrassing question. Where is rm.c? He's like, oh no, I just made all that up. I'm like, he's like, but he said, but there should be a Robert Mustacchi Appreciation Week. I'm like, all right, there we go. There we are. There definitely should be. So
I think better off without it.
Or Robert, we are very grateful for you joining us. And so here's what and actually it was funny because, just earlier today, we had someone by the office who was asking about how have you managed at Oxide? How have you done hardware software co-design? How are you able to do that? It's just it's organizationally challenging. It's obviously technically challenging. And I was like, you have to tune in to the podcast tonight when we have Robert on for holistic engineering, because so Robert, you and I have had the blessing of working together for a really long time. For much of your professional career and much of my professional career at this point too, but I guess a greater percentage of yours, just given our relative differences in age. But you came out to Sun originally to microelectronics, right? As an intern in 2008, maybe? When was that?
Yeah. I did a brief stint on the KT verification in Burlington. Right. And, you got to see the glory of a microprocessor that would ship really soon. Not ship. So you kind of got to learn lessons that we're seeing today. From when you see Spark roadmaps from some of the other CPU manufacturers, you gotta
right exactly. I've lived that, right? Okay, so then the next summer you interned. It was the next summer that you interned with us at Fishworks in San Francisco, right? Is that right?
Yeah,
right. And that was great, obviously. And then we had,
if I may, I'm sorry. So first of all, please. His internship was great. I can't take anything away from that. I would say that the thing I remember
Where's this
most
going?
from that internship is that Robert then and continues to be an amazing baker and maker of confections of all kinds. And I think it was that
That is
internship.
true.
I think it was that internship.
Food for
where
Money
Robert-
Friday.
Yes, which spawned. I mean,
it is true.
The
A social
cheesecake
movement.
brownies that launched 1,000 ships. But
It really did launch 1,000 ships. God, Adam, I'm really glad you mentioned this because people thought they were tuning in for holistic engineering, and they're actually tuning in for the origin story of what we call Food for Money Friday. So, do you, Adam? Would you want to? Robert, may Adam do the honors to tell the origin story of Food for Money Friday? Because I do think it's important.
Sure. Yeah, I can add my commentary. The background thoughts I had while different things were going on.
Director Scott.
I do want to sort of get to the actual point of like what we're talking about, but I would just say that first
The
of all,
point of what we're talking about is Food for Money Friday, sir.
Okay, good. Then allow me to digress. So Robert brought in these cheesecake brownies, which I think, Robert, you said took like all the butter in every Safeway. You had to like Smurf butter from all the different Safeways in San Francisco.
Well, there's no more. I mean, we used up. That's why there's an egg shortage now. So
that's right.
Yeah,
so
that's right. That's why butter is in this packaging. It's really hard to open because Robert was smurfing butter back in 2009. And so they put a lot of legislation in place under lock and key. You got to ring the bell. Someone comes and locks it for you anyway.
It's California.
Yeah.
So Robert brings in this delicious cheesecake brownie with 1 billion calories. And I can't remember. I think we had already gotten to some like light food betting here and there. And I think I said something
I don't think that part's correct, but okay. Yeah.
Well,
I remember this so vividly.
So I think I was like, Brian, I'll pay you $5 or whatever to eat the rest of it. And there was a lot left. And I think you in a rare act of self-preservation.
So it is my recollection. Robert, go ahead. What is your recollection?
I was going to say that basically there's about 1 inch of a 9x13 on the 13-inch side that's been gone.
Yeah, it's been gone. And my recollection, and actually it's interesting that we've got like the difference of dollar figure. I recall it being $10.
Okay. Well,
but maybe it was $5.
Inflation adjusted.
You say I'll give you $10 to eat the rest of it.
Yeah.
And it is like 10:30 in the morning.
Which is going to be important later. Yes.
So I am extremely intrigued by this offer. This offer is extremely interesting to me. And I feel like this is not something that had happened in the past because I just felt like this was like a bolt of lightning from my, maybe call back to my youth of like, we can actually, we can earn, I can earn money while doing what I'm best at, eating. So this is like, okay, I am extremely interested, but I have to leave for a meeting. I have got like a.
So it wasn't self-preservation. So the other thing I remember is
self-preservation. I absolutely wanted this. You have made an intriguing offer, one that it didn't even occur to me to counter offer.
What I also remember is that even before you had declined the number, like. As soon as I said, $5 or $10, everyone else on the team was kicking in. It was up to $75 almost immediately.
That is my recollection too. And like an idea whose time had come, this just exploded. I mean, everybody, that's like, I had to run for the meeting and it felt like within seconds, the pot was at $75.
Everyone's like, I too would like to see this person commit ritual suicide.
Right. And then our colleague Julie gets wind of this and she's like, wait a minute, is someone offering $75 for someone to eat all of that cheesecake? Like I'm definitely in. I'm going to eat it all.
Yeah.
It's like, great. I leave.
That's right. And we had some time-based constraints that I won't go into the specifics of.
I don't want to go into, I don't want to go to the entire IOC rule book here in terms of was it a sanctioned event? There's there's a lot of, and I came back to Julie looking in front. Robert, what is your recollection? I recall her having like 1.5 inch by 1.5 inch square remaining.
Something like that. I mean, I'll admit I was kind of in shock the whole time. You bring this in, you're kind of trying to sort of be like, hey, here's something nice for everyone. And then it's like, then it becomes food for money.
This thing that I thought would be a delicious treat for everyone, I guess, has become your prop bet.
Robert, I guess, am I an accessory to a crime or merely to very poor judgment?
And definitely ruined cheesecake, I think, for Julie for some time.
Oh God! But yeah, Brian, it was like an inch and a half by an inch and a half square.
Yes.
And you're just like, Julie, well, just like, come on.
I know. I was like, just put it in your mouth and force yourself to eat it. She's like, that's what I've been doing. That's what I did for the last 4 of these squares. Like I've already, like, I literally can't look at it without wanting to throw up.
So now this is the part of the story when usually I tell it to folks and I'm like, and then Julie couldn't do it. So she didn't get the money. And everyone is aghast. Wait, you didn't give her the money? And I think, no. I don't know. What kind of lesson are we teaching the children? And this was,
yeah, exactly.
And we had an arguable child with it. Like we had Robert as a young adult. Robert as a college,
a very
college
poor
student.
example to the intern who was shocked and aghast that we had taken his very kind gesture and turned it into something that was just depraved.
That's right.
But no, she didn't get the money. She got the cheesecake. So it's like, oh, Robert, I can't believe you worked with us anyway. We're so grateful that despite it all. So we will absolutely need to do a podcast episode only on Food for Money Friday. But let's just say we've had other
a teaser episode.
This is a teaser episode. We have had other Food for Money adventures over the years, and Robert was not for the last time with the intern involved. So we have, which has become increasingly ambiguous for me. As someone in the chat is asking, is this hazing? It's like, don't know that we actually volunteered to what we were doing to some legal.
Yeah, no, I mean, and no, we weren't like, a ritual of, I don't know, whatever position was to like eat 90% of a cheesecake. No, this was all voluntary. These were all consenting adults.
That's right. Hazing there are many attributes of hazing that are absent here. There is nothing. Yeah, exactly.
So there actually is another, there's a kind of bait and switch follow up to this internship, which is Robert interned with us. It was great. Cheesecake included, but not the only reason. Great internship.
Work, yeah. Great.
Goes back to Brown University, finish out, get his degree, and we made Robert an offer to join us full time, and he accepted. But in the meantime, we were off getting acquired by Oracle.
Yes,
and then you and I were off figuring out how not to work for Oracle.
Yeah. And I felt so we had, and Robert, I left what was then Oracle before you joined. And my recollection is that I reached out to you as I was leaving. I think I did anyway. I certainly felt very bad that you were going to be joining a bit of a ghost ship.
Yeah. And Robert joined, and I don't know if it was clear that I was leaving but I was like, Robert, it's a great learning opportunity. Is me teaching you about all the stuff that I've done and everything that I've ever owned in case it comes up. And then I think I left 2 weeks later.
Something like that. Yeah. It's a good learning exercise.
There we go.
Yeah, it was not. So, but fortunately, Robert, you joined me at Joyent. And you and I did a ton of things together at Joyent, but something that you and I worked closely on early on was the port of KVM to SmartOS, to our Lumos derivative at the time. Was that? I mean, what is your memory of those years? I mean, that was a bit of a terrifying project in that we really needed to succeed, and it was really hard. But so you and I worked very closely on KVM, which was great. And then when kind of in that, so what my also kind of memory of those years is all of the kind of our early interactions with Intel, and you really owning that kind of the interaction with Intel. That seemed to have happened pretty early on at Joyent anyway. Is that an accurate recollection?
Yeah, I think we had some very early bits at 365 California. And then it was actually, I think, when Keith came on.
Right.
He kind of was really driving more of those programs, and I was working with him there. And then I took over more and more of that as Keith retired to the farm for the first but not last time.
For the first but not last time. And so, I mean, I obviously always have had an interest in low level software engineering, and I've always kind of been at that hardware software interface, but definitely found yourself there very much at Joyent. And well, do you have anything formative that you want to talk about? Because there's definitely something formative at Joyent, obviously. And I don't know, Alex is here in the chat, but we definitely had there were many episodes over how many years were we together at Joyent? Almost 9 years at Joyent. But at that kind of that low level system software interface.
I don't know. I think a lot of just learning how to learn and learning how to debug, especially in those early years. Because there's a lot of times where, I might know the kind of question I wanted to ask, but not how to ask it. Or, you or a lot of the rest of the team would kind of come in with some of the dtrace or other bits there. And I feel like also we're one of the great adages that I've kept in mind when being faced with gnarly problems, which is basically write debugging tools when you're stuck.
Yeah, interesting.
Right. I don't know. I feel like that's a lot of it is during the times of really just figuring out how do you go learn a new subsystem that no one's been in really before, and there's no one to go ask. Right. It's not like you can just like go ask how does this how does the net stack work, or how does the USB stack work? It's like, just go use some dtrace, go use some MDB, and start figuring it out.
Okay, so this is a really interesting point about kind of learning how to learn and help not being on the way. Like, there's no one. You're in a subsystem where there is actually, like, you are going to be, if you're not already, you're going to be the local domain expert. So do you have a particular methodology when you're going into, because one of the things that you, among your many special attributes, you're a terrific code reviewer. And how much do you go into a kind of a new subsystem just by looking at like the actual code?
I'd say often there's some kind of group of questions I'm trying to ask or answer. And it'll be some combination of looking at codes. Basically, almost always have C-scope with Vim integration that I've inherited from Dave and others over the years. Enough that I can sit at Dave's keyboard and we can have the same key bindings, which is shockingly convenient.
Wow. God, that's amazing.
But that and using that with a combination of dtrace. And this is where I'm trying to think of this. Some of the classic one-liners, like instrumenting a module, like all entry probes in a module and aggregating on probe func is one. Aggregating on certain stacks and just seeing what happens. Trying to trace control flow or data flow.
And then do you, when you're kind of in a new subsystem like that, trying to ramp up on it, are you like writing down questions that you're trying to answer? I mean, how do you?
That's actually a good point. Because I think one thing that I've noticed that is having questions in the notebook and writing stuff down in there. I think that's one of the other things that I've found really valuable is just trying to figure out what are you trying to do, or trying to diagram out on a whiteboard how the subsystem works and flows. I think I remember we were debugging one of the, what was it? There was something with the X2 APIC, the Apix PSM driver, and that block diagram is now in like OSInter.c, but it filled up like 2 Joyent whiteboards. And a lot of it was just trying to understand, like, how can I understand this control flow well enough to know, like, what's going on, where's everything flowing, etc. And that's definitely a useful, just kind of, how can you understand it well enough to explain it to someone else? And I think that's the other thing is, I was often sometimes sitting there talking with other folks in the office, or on chat, and using that as a way to kind of like have them ask. Sometimes they would ask me questions. Like, I know sometimes Josh and I or Dave and I or Patrick and I would just go there and like or Alex, we probably did this a bunch at 655 Montgomery. I remember there's that little bench behind near Dave and Josh's desks. And I feel like there would be a lot of kind of questions and back and forth there. I'm just like, how does this, if kind of the old like adage, one of the useful things about it being a TA is by the time you can finally explain to someone else, you might start to have an idea of what's going on.
Yeah, that's really interesting because all three of us were TAs as undergraduates. It's very formative for all of us. And yeah, this is not a deep thought, and anyone who's taught knows this. But boy, when you teach something, you have to learn it with a whole different level of mastery. It's not like you can even do well in the course, and then you go to TA and you're like, oh my God, how did I even like pass this thing? I barely I'm learning so much more. Because when people ask you, sometimes people will ask you a question and you'll give an answer. Well, they'll be like, oh yeah, that's like a convincing answer. And you're like, that is not like you are convinced by this answer because you're asking me the question because you don't actually know, but I actually know the limitation of my own knowledge and I have not given you a very good answer actually. And I actually need to go research that because I'm not, so that's interesting. And then Robert, I also think it's interesting that you mentioned the block comment that actually gets, because your block comments are, ne plus ultra. The ASCII art in your block comments is the stuff of legend. And I say this as someone who prides himself on his own ASCII art in my own block comments, but
honestly, it's mostly just because if I don't do it, I'm going to forget it all. And having it written down, like I've gone back to some of these and been like, oh, good job, past me.
Yes.
Like, I'm glad it's here because
I was just going to say,
I forgot this entirely.
The number of times we often talk about past Robert around here, and you will be like, we'll have a question. You're like, God, I don't know. I'm like, actually, past Robert knows the answer to that question. I actually know that. And then, like, fortunately, past me wrote this down. I have heard you say that so many times over our shared career, and. But it's so because you mentioned that like when you're stuck, write debugging tooling. I definitely agree with that. But when you're stuck, you also write a block comment and you can go make an artifact better by just explaining how it works.
Yeah, I think as I've been flipping back through my notebook here for things that are things that aren't meeting notes, a lot of it really is just a whole bunch of things around like. If there are problems, it's like starting with questions that I'm trying to answer and go figure out what those are. Even on Thursdays or Fridays, LRDIM hunt is the same thing.
Yeah.
Just like what are some of the things? What are some of the observations? What's different? And I find that writing stuff down is a helpful focusing thing, and that at least for me, I learn a lot better. Everyone learns in different ways, so it's not going to be the same for everyone. But for me, physically writing in mostly illegible cursive that looks good from a distance is
Robert's cursive is remarkable. I think it's fair to say. It gives me great like Robert. There have been times when I have asked you to go back and read your own cursive, and even you can struggle. It is beautiful, but it's just like it's got this very. Obviously, you've seen plenty of Robert's cursive. It definitely, I feel like I'm reading a letter that Alexander Hamilton wrote to me. You know what I mean? It's got that kind of like 18th century vibe to it, totally. Which is like this is it's gorgeous, but I just can't make it out. So, Robert, this was all. Kind of as the years go by at Joyan. You're going into like. Kind of rappelling down into deeper and deeper caverns. And then personally, I feel the ne plus ultra of this was on January 1st, 2018, when we saw a rather disturbing story on the internet. I assume. Do you want to describe what we saw on the internet and where that kind of led you?
Yeah, actually, I think my memory is that it was like you or Alex probably saw it first. Probably with Spectre and Meltdown. Kind of this is being like it's put back in Linux in a way that starts leaking and everyone's kind of denying it until they stop denying it. I think is the
yes, and it has become a Hacker News story on January 1st, 2018, if memory serves. And I think I am I mean, certainly, Alex, I'm sure saw it first. I definitely DM'd you, being like, do you think this affects us? You're like, I don't know. We're learning about this for the first time. And this is us learning about Spectre and Meltdown, and then discovering that we are vulnerable and we are running in production in a public cloud. And Meltdown in particular was really, really acute. John Masters had done terrific work having a real, like, vivid proof of concept of Meltdown.
Yeah, how many Intel CPUs did you have deployed at this point? It can't have been that many, right?
Yeah. It's funny. Like, that is definitely, like, not a question we were going to go answer, because it was just like, it's not actionable. You're just like, how far is it down to the bottom? And it's like, it is enough. And you're at a height where you're going to die, and nothing else actually matters. So it's like,
beyond that, right?
Beyond
more
that,
more than 10.
Yeah,
it was a lot. And Alex and Robert needed to go implement kernel page table isolation. And I mean, Robert, maybe that doesn't stand out for you as much as it does for me, but that is one of the singular engineering efforts I feel I've ever been kind of in the proximity of. I mean, it was really extraordinary under, like, the just on the one hand, maybe the pressure was clarifying, because you're just like, well, I didn't create this problem, and definitely, like, it's very clear what to go do. There's not a question about, like, what is the highest priority thing to go do, which I feel is something as engineers we always grapple with. It's like, the highest priority thing is to go do this neurosurgery on the VM system.
Yeah, there was a lot of different parts to it, and so it was a combination of Alex and also John Levin. Who
right.
Was, was very helpful to have while working on that, and obviously lots of conversations with others. But there was we were able to kind of split up that work into a bunch of different pieces. I think I dealt with per CPU page tables, which was an exciting thing in its own right. I think Alex dealt with a lot of the trampoline assembly, but we also kind of settled on a somewhat unique solution, I feel like, that hadn't really been done by others with the per CPU page tables. But
so could you talk a little bit about the problem we were solving? Like, what was the problem that we needed to go solve? What actually is?
Yeah.
This is to be clear, this is for Meltdown, not for Spectre, but Meltdown was a much more acute of the two.
So that's a great question. So on x86, ARM, and a bunch of other and common RISC-V CPUs, when you use the MMU, you have page tables that describe virtual to physical mappings. So every process is its own address space and maps to generally disjoint physical memory, and those page tables describe where they exist and different attributes. So some of those attributes say, this page can be read, this page can be written, this page can be executed. One of the attributes are basically permissions in terms of what the privileges are required to read, write, or execute that page. So you can really kind of think of this as that there's a whole bunch of memory that people sometimes call kernel memory, and then memory for processes. But effectively, if you kind of take, let's just use the 4 gigabyte 32-bit address space as a simple example for a second. Every process has a 4 gigabyte address space, or 64-bit process has 64 bits with a bunch of holes. But the top gig in that 4 gig address space is always the kernel, and it's the same in every process. And that's there so that way when you make a system call, you can start executing kernel text, and you don't have to go try and basically change the MMU context, change the page tables, because that's generally expensive and potentially causes cache invalidations and a lot of it's the root of a lot of CPU performance challenges. So,
and this has always been in x86. I mean, other architectures have done, like Spark did things differently.
Yeah, Spark had
with address space identifiers.
Tables. Yeah, exactly. Yeah. And ARM, through various incarnations these days, especially in the 64-bit ARM v8A profile, looks very much like x86 does in that regard. But effectively, there's a bit in there, or a few bits that say, should this page be a kernel page or a user page? And effectively, what that's meant to say is that if you're a user process, even though those kernel pages and those kernel VAs exist, if you try to read them, you'll get a page fault, and then the kernel will come and drop a signal on you to basically say you've been reading something that you can't. Unfortunately, through the power of speculation, what basically happened is that that check happened, but after all the side effects of doing the read were pretty much done. So everything other than, it doesn't show up in your register, but it's impacted, but it was loaded into all the caches and everything else, such that you could still see it. And basically you could read any arbitrary piece of kernel memory you want. So whether that was someone's packets, security keys, someone else's file system cache data. It was
And to be clear, the way you would do that is because what you are controlling that you should not have been able to control, but you are able to get this thing to do a load for you, but you can't see the results. So the trick is, how do I exploit the side effects of that load, namely allocating in the cache? And then what can I go do to exploit those? And the things you can go exploit, as it turns out, you can have a conditional branch that then also gets executed speculatively. And then that can do something else in the cache that you can then go observe the side effects of. So you can kind of chain together. People may want to know, because I think one question people have is like, well, wait, why didn't someone discover this a lot earlier? And the answer is like, it's sophisticated in that you do have to kind of chain these things together. And I think that this had been kind of in the abstract. We knew that kind of speculative attacks could happen. I don't think anyone thought that they were going to be this brazen. And in particular, it is really bad that it would speculatively execute on these addresses that you don't have the ability to read. The chip should never have done that. And
yeah, there have been a bunch of a buildup in the literature of kind of different L3 cache attacks of kind of like prime and pump and other things, where you kind of start using L3 cache as shared resources, but people didn't expect you could kind of go through the page tables. Or my favorite one really is eager FPU, which is kind of just a fun one of just like, oh, you really can speculate through everything.
You really can't speculate. I mean, with eager FPU in particular, and this is like fast forward now, I don't know, maybe 9 months or 10 months, and we're having kind of these constant calls with Intel where they're revealing yet more, because it is also true that like once the group discovered Spectre Meltdown, and I mean, we knew this was going to be true. It's like, oh my God, it's going to be an absolute bonanza, because now people know this is a target-rich environment. And I can now go explore every unit in the part. And Robert, I think it was with Eager FPU when I had missed the call with Intel because of another conflict. And you said, well, we've got another disclosure. What is the one unit we have not yet heard about from them? And I'm like, we've not heard anything about the FPU. You're like, yes, it's the FPU. It's like, oh my God, literally every unit.
Yeah. But yeah. I'd say that's been one of the small advantages of working for smaller companies, that you get to explore a lot more of this stuff than you necessarily do at kind of some of the larger places, because there's just we're less cemented teams, so often there's not like a big kernel org sitting by, or
right.
Even if you look at like Apple, what they have a lot of different groups there, so that a bug comes up, you're going to pass it off to that group, and you're not going to chase it down or look at it or have to figure it out, which is sometimes both a blessing and a curse. It can be great to have, it's great to have a lot of different colleagues, but sometimes it means there's less opportunities for you to learn or kind of move around in that regard. So
I'd also say, Robert, if there's fewer opportunities for you to, I think one of the things that you do well, I'm sure we're going to get into this, is cast that eye that is so well informed about disparate parts of the system. And I think that you're right that like a strength of a large organization is that you can have experts narrowly focused, and it sometimes is a lot easier to be productive along those lines. But I think what they miss is the kind of system-wide insights that you've been able to make, at Oxide, for example, because of your awareness, because of diving deep into all these different areas.
Yeah, I think that because I agree, Adam, and I think that like, don't know, Robert, sorry to speak about you in the third person, but I feel like that is something that I feel I've kind of have seen more at Oxide, where it's like at Joyent, like you dove deep into so many different domains. And then coming to Oxide, maybe it's a good opportunity to kind of fast forward to Oxide a little bit. But when we started the company and able to raise money, and we're able to convince you to join us, and you'd been thinking about a lot of these, you'd gone deep in a lot of these disparate areas to the point that you were now really beginning to synthesize them. And maybe it was just that Oxide gave us the opportunity to do that synthesis. But is that, I mean, as you kind of think about your own story, is that kind of when that synthesis really begins to come into focus?
I think it's when we're able to execute it most directly. I mean, so I think there's you remember Keith and I had, like, Keith was driving together. We had kind of this dog patch pitch. Must have been 2015, 2014.
Yeah.
Maybe 2016 at the latest. Can't be that much.
No, I did not 2016. It'd be like the 2014, maybe even 2013.
Yeah. Of kind of where we want to go, but with the constraints, that, effectively, we're not doing our own boards. We're not really getting to that low level access. How do we work with folks there? And at the same time, there's broader business constraints around, who you have to work with, what's available on the market. Ultimately, we have to be economically minded in different ways. So,
but Robert, can you talk about more like what problems you were trying to solve with Dogpatch and what were the solutions? But before you get there, I just want to say, Bryan, you mentioned hiring Robert. You failed to mention that he was actually your first hire. So he is employee number one.
The first hire, and also I feel I'm so desperate for Robert that as soon as Robert kind of like tentatively said, like, I guess I work here now. And we were both like, yes, you work here now. Yes, you work here. There was a moment of just like, okay, like, sorry, Robert, you can't take it back. Now you work here. But we were, I mean, and it takes a special, like, and Robert really obviously appreciate just like because the company's nothing at that point, and like, and again, I know vividly where I was anyway, Robert. I don't know if you remember where we were, but on kind of Jess's little back deck there, as you'd obviously had some questions. I felt we kind of knocked down all the questions, and you're like, all right, I guess I'm in. I don't know. I guess I'm joining you.
I know. I'm with you. It's like raising money. Certainly, it gives you that feel of tangibility, but it's when other people are now saying, people you've worked with, in Robert's case for 5-10 years or whatever, saying, yeah, okay, I'm in. Let's do it. It's a new kind of reality setting in about the venture you're heading down. Yes.
Yeah. And not too long thereafter, and I want to get Robert back to Dogpatch in a second, but and I'll definitely drop this photo into the chat because I've got. Robert, I'm sure.
Is it the whiteboard photo? Yeah, because I was about to say, if you have that, you should drop that in, because I feel like that's emblematic of the discussion we have. It's like, let's drop these different pieces on the whiteboard. And then we go back and forth, like, let's talk about what's connected. And you're like, they're just going to be fully connected. And of course, you were right. But
yeah, I mean, it was really great because we had all of these different. So we've got all these kind of different elements of the system, and Robert is like trying to figure out, like, okay, what are the kind of the connections between the root of trust. And we've got the switch, we've got all these different elements, and I'm like, this is going to be a fully connected graph, and sure enough, it after not too long, it was. So yeah, I'll drop in that photo, Robert, but it's definitely a great one. But would you mind actually, just to go back to Adam's question, like, what was Dogpatch? What were the problems we're thinking of with respect to Dogpatch?
Yeah, so I think to really start to get at Dogpatch, I actually had to rewind to actually back to Fishworks and AK, which was the appliance kit. So there was a lot of hardware-software integration we did there around manageability and serviceability in particular. And if you were ever fortunate enough to use one of those, there was a lot of things that did around just like, hey, detecting drive failure, indicating that, blinking an LED, and even being able to blink the LED, tell you where it was, already started resilvering, swapped in spares, sent out emails, did contacted support potentially to get replacement parts shipped, etc. And that was kind of at a single box level, and that was really 2007, 2008.
Yeah.
Then you kind of fast forward, and it's even 2013, 2014, and the ability to kind of deal with that data center management at scale, kind of getting to that warehouse style computing, is really limited unless you're one of the really big players. You're making an LED blink reliably, surprisingly challenging. Actually, honestly, in half the times, even after you figured it out, actually you've learned that the server was built incorrectly, and on a bunch of things to drive, to the basically SAS expander, or maybe the drive, basically the drive backplane cables were swapped. So what you thought was drive 0 was drive 8.
And so you were literally lighting the wrong LED.
The wrong LED. So,
hey, a drive failed. Come on, I don't know.
Exactly. Actually, like a drive failed, so I want you to remove one of the good ones.
Did that help?
Did that help? Exactly.
But also, all of this had to be done very manually, and the joint operations team put a lot of work into dealing with and managing that, and dealing with the kind of lack of features. But the serviceability and manageability story, which worked good at the 1 to 2 system, or if you had multiple systems, at Fishworks, we really wanted to bring together. And actually, go see if I actually have this deck still somewhere.
Yeah, the dog patch deck. We've got the dog. Yeah. It's
just to remind myself what else was actually in there. But I think this is actually where I think the big thing is, there's a lot of fights between what's being done by the OS and what's being done by the BMC in those systems. Because basically the BMC is basically where there's a whole bunch of value add from the vendor, for varying degrees of value.
Oh my God, Diet Coke just almost came out my nose.
I know. Those air quotes are just like screaming.
Oh God, yeah. I needed a little bit of a warning on that one.
And just the features that the Adam Billing had were challenging.
Robert's being very forgiving to not mention this, but this is when we first heard about Redfish. For whatever reason, I somehow I'm like, I think this can really help us. I'm like, Redfish, this seems really interesting. This is going to solve exactly this kind of problem that you mentioned. And I remember you being like, I don't think you understand what this is. Like, that's not gonna, no, sorry. This is taking an HTTP layer and smearing it on top of the same garbage. This is not going to help us at all. And of course, everybody's like, no, wait a minute, I'm sorry.
But like, that is the marketing of it, right? Like that is the ostensible value add of Redfish. Just it's totally divorced from reality.
And it's gotten slightly better than when it first came out as a empty schema. But as I'm trying to look through this to see some of the other things, like obviously, some of the classics, dealing with firmware, the different kind of architectural challenges we had there. We actually were thinking about how do we eliminate the BIOS and UEFI and basically just do a small, basically let the bootloader take care of a whole bunch of stuff, that for us was iPixie at the time. So it's just like, how do we basically just get out of these different layers that are differently broken? I think this is during as we were writing this is one of those times where we had, I think it was like a Dell, maybe like Haswell era server. And after we typed reboot, it would just hang in the BIOS. Like after we, we just reboot, God. And it would only happen on a warm reboot. And there's a lot of back and forth of being like, well, it's your fault. Dell telling us this. And it's like, and you're trying to like, some of us would say it less politely, I think, yeah, this is where we had good cop, bad cop, and psycho cop. But it's like, hey, the bias is just like erased all of our program text and it's taken over. How is it, and its job is to restore it from an arbitrary state. So how exactly is it our fault? But actually, that in and of itself is a lesson as to one of the things that we actually did in Oxide, which is getting rid of 2 different reboot paths to actually simplify the system and streamline things. So that is, in a standard system, if you type reboot, it's not going to do a full post. It's not going to go reset everything. UEFI is going to kind of be clever, and or the real reality is that the CPU actually isn't going to erase everything. So even if you reassert the reset line, if you're in this ACPI S5 state, there's a whole bunch of state that stays across that. So that all of a sudden means there's 2 different initialization paths. Some of this data you'll see is in some of these data sheets described as being in certain power wells or is sticky across resets. And so we're just like, let's have none of that. Let's kill all power. And that actually made it easier for us to build a more reliable system with actually less, with less code paths to actually think about, because we can actually say there is no warm reset. There is no way there. And then at the end of the day, what that means for customers is that, hey, it works more reliably more of the time. Because a lot of the challenges here is that you have all these different code paths, and it's hard to actually test reset in a bajillion different ways. Or what does it mean to do a warm reset when, you've been up for 2 years versus you've been up for 30 seconds versus, I've hot swapped all these drives up 10 times versus, I've done nothing because I've just been up for, 2 minutes. So it really got us out of that problem once we ironed out some of the bugs.
Yeah, so and this is at Oxide. This is not something I dropped the dog patch deck from Joyant into the chat, Robert. But the circa 2014 is when I've got it. So and actually there's actually 2014 on there. And you will see a lot of the Oxide vision there in terms of illuminating both bias and UEFI. Much easier said than done. And
well, no one took us up on it, so
no one took us up on it. And so, a bunch of things. I think this is the kind of thing that nobody disagreed with us that this is the right thing to go do, but it just seemed like, God, it seems really, 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 really hard. AMD thought it was impossible. And it was in order for us to, this is the part that is not well documented. Do you want to describe some of your trials and tribulations about like, how did we do this? How did we pull off this? Because I think this is, fortunately, like we had AMD's cooperation at the level of AMD was not going to like get in our way, right? AMD is like, what you're doing is so hard, we don't know how to help you, but we're also like, we're supportive of this effort in the abstract, which is extremely important. But it's also like not hugely helpful. How did we go about on that particular problem?
They're helping by not actively sabotaging us, is what it sounds like.
Hey, listen, sorry. Like,
you'll take it. You'll take what you can get.
Like, that's ahead of the class for you. That's terrific. They actually, they did actually one better in a very important way. And this is why people may have seen the OpenSil effort from AMD around open silicon initialization. We are very, very supportive of that effort, even though we're not using it at all, because it was tacking in AMD. AMD was going in a lot of the same directions that we were going. So it actually, but that didn't, like what we were doing was far earlier than before OpenSil was really just kind of still in its kind of earliest phases. So we really were on our own. And Robert, talk about, this surely the work that you did there to understand Agisa has got to rank as one of your most challenging projects in terms of understanding a foreign code base.
Yeah, I'd say it's even more challenging as of one that at least at the time, there was really no good way for me to build or run or instrument. So that was really all about code inspection.
Robert, can you talk about what Agisa is and like where what we needed to do in that domain?
Yeah, Adam, that's a good question. So Agisa is effectively one part of AMD's boot software. So it contains both the all the kind of binary blobs that the PSP or other kind of hidden cores run, but also really contains a whole lot of all of the x86 initialization things. So, how do memory mappings get set up? How do various pieces of the data fabric of, CPU initialization, turning on, and, when you start, there's only one CPU turned on. And even though operating systems have this, traditional IPI dance, there's a whole bunch of other stuff you have to do in advance to start this. The AMD SoCs, like others, has 128 PCIe lanes, but those PCIe lanes can be carved up into arbitrary different slots depending on what board you have. So how do you communicate that? So AGISA, which I guess it looks like, what does it stand for? AMD Generic Encapsulated Software Architecture.
Only one of the letters is an acronym.
So that whole bit is designed and ties into a separate, these days, UEFI code base. So it in and of itself is not the complete picture. You also need, so basically it's built up as a series of UEFI modules that runs in the PEI and Dixie phases, which are different phases of boot, and still means that you need like a Tiano core or other UEFI implementation to kind of fit alongside it. It will do anything and everything from setting up I2C devices to, that's where SM BIOS tables are created, to just,
It's presumably where ACPI tables are created as well, right? I mean,
ACPI tables are created there too, and just a whole bunch of stuff. So that was an effort where,
and so it also should be added, Robert, that so you're like, okay, so you got this like early platform initialization thing, so you have to like follow all just the code flow through that. It's like, yeah, about the code flow. Do you want to describe what makes following the code flow through here absolutely brutal?
Oh, yeah. So, as I said, these are all UEFIs designed in a series of different modules. And they all basically rely on different callbacks firing. So because these modules are kind of coming up and loading in probably somewhat defined but arbitrary orders, they'll often wait, So before I begin, like the PCIe module or the NBIO module might start loading, but it's going to register a callback that fires when all these different PPIs, which is a UEFI term, are provided. And there's lots of them. And there's not like or at least the things we had access to, there was no clear map of like, this is the expected ordering of these different sets of services. So it's like, when does the logical SoC service begin? When does the memory map service start? What is it blocked on? So a lot of it is basically trying to come up with this effectively callback-driven control flow, and trying to understand what is that just by purely reading, which is not straightforward and definitely not always correct.
Well, and so like, unlike with the kind of other things, where like when you went into the page tables to understand the VM system, you're armed with the source code, and you also have some tools that you can use to actually observe the running dynamic system. You don't have any of that here. You have, or very, very little. I mean, I guess the thing that you could, you can go dork with some of these attributes, these APCB tokens, and you can, I guess, watch how this is. And I guess you did do that because I know at least once you're like, could you go over to this machine and see what's happening? Because I was in the office and you were not. And I'm like, this machine, yeah.
I'll say that. So that was a very different. That was dealing with one of the hidden cores.
Oh, right. That was actually sending messages to, right. This is on our own software. You were not actually trying to understand their software. You're actually running our own software.
Yeah. Yeah, that was in our software. We're trying to send a message to the hidden core, which is responsible for PCIe initialization. We're basically trying to send it a data structure that has, all the mapping of all of our lanes and all this fun stuff. And then you send a message, and as you know, we then wait a while, and surprise, it came back to the bootloader prompt, which is never a good sign.
Never a good sign.
The kernel's up, so like in theory, if I, normally if I take a page fault or a double fault, you trap into KMDB and, you could debug. And that's when I started asking Bryan, like, what's going on with the system? And,
it was powering off. Yes.
Yeah.
It was. This is like you were putting a message in a bottle. There are a lot of like messages in the bottle where you're putting a message in a bottle, you're sending it out to one of these other hidden cores on the die. And in this case, you're putting the message in the bottle, chucking it towards the island, and then the island was somehow like bursting into flames and sinking into the ocean. You're like, I don't send that one, I guess. Like, okay,
yeah,
like, okay, that's a no thank you on that message. Let me go.
The island launched global thermonuclear war. So, we all,
yeah, exactly. Like, whoa, okay. And it's brutal.
And that one came down to a missing write to one of the registers in the effectively the MBIO, which is Northbridge IO, which has parts of what the memory map are. So we were basically trying to do DMA to an address, and it didn't have it was missing information that told it whether that was DRAM or memory mapped IO, and so it probably hit some internal error. And especially since then we didn't have good observability. We were still working on a reference platform, so we didn't have our service processor, our other stuff there, so we couldn't see if there were some of the low level asserts were being fired that would trigger something on a pin.
Right. We had nothing.
So how on earth did you do this? Like, what was it? Just back to the code and reading more? Like, it just.
Yeah, well, and I think this also gets to some of the tooling stuff. It's like we had actually built up a whole bunch of random dmods in KMDB because there was no user land. So it's all in the kernel debugger to basically be able to read and write some of these different register spaces. So there's the system management network is one of them, and then the data fabric is another one. And having that tooling be able to do that just let us kind of do some inspection. We use this in other problems because we could that is something that we could use on our without the Oxide architecture. So we actually sometimes would compare and contrast that to what we saw on ID6 PC, on a standard PC. But for this one, it was really code inspection, double and triple checking, rereading, getting it wrong a lot. And I don't know. There was a bit of a a lot of the time it's kind of a blur, I'll be honest.
Were the iteration loops on this just like 5, 10, 20 minutes? I mean, it sounds
depends.
It's a lot of it.
Go ahead. Yeah. The actual boot and like load time isn't that bad. It's really more of the mental effort there, I'd say. Just like knowing what to do next.
I mean, you would kind of love to have so much to iterate on that you're blocked on the iteration loop, which is like 20 minutes, but like that's not even the problem. Like you have the despair loop, which is actually much longer.
Oh yeah, I mean, I'm factoring in the trip to the therapist and then the drive back home, and right.
That's right. Well, and I do wonder on some of that stuff because in Robert, you so frequently you tackle these problems where the stakes are high. Like if we don't resolve this problem, we've got a serious issue. But you've always got like a very cool head when you go to debug these. Do you have like do you just have like an innate sense of confidence? Are you not as scared as I am? I'm terrified. Are you not terrified?
No, don't worry. I'm plenty terrified. And I think
that actually makes you feel better.
I think part of it is also that I actually am never doing this alone, no matter where I've been at. Even if other folks don't necessarily have all the background. That time, Keith and I were working together a lot. But other folks would sit there, help listen to things, And this has been true when I've been debugging up and down across the stack, whether it's software, whether it's hardware. It really is a team effort. And even though some of the debugging is there, is sometimes a solitary activity at first. A lot of the other pieces like writing it up, having, especially Keith and I, when we were doing Bring Up, I think the fact that we were working together, even though we're tackling different parts, means we would write up different things in some of our bug reports, review each other's notes, ask questions of one another. And the act of asking questions and being forced to answer them is there. That's been the same thing that's true when we've been debugging, some of the T6 stuff, which Nathaniel and I were working on recently, or other things that we're doing that are up and down across the stack. Is I think the first thing is that you're not alone and you have the expertise, or just the different perspectives of all of your colleagues. And I think that's really invaluable in and of itself. Because they'll ask you questions that might make you think in a different way or prompt different thinking. And it can never be just yes, sometimes you need some time where you kind of you get off the world and just kind of stare at things. But really, it is working with others, I think, that ends up being necessary to kind of get through some of these harder bits. Because that's, I think, partly what helps you get through it. Because if I'm stuck and I see Keith making progress, and that helps there, or if I see us making progress, on the board work or higher up in the the control plane or other parts of the product, or down below, then that kind of helps motivate you to kind of keep going. And it's not all bad, but
right. Well, and I think that because it's part of what is so kind of remarkable about the way you are able to approach the system is you do oscillate from the absolute lowest layers of implementation, like really stuff that is often like does not have a lot of eyes on it. I mean, like the deepest aspects of system implementation, ones that are absolutely required for system correctness and liveness. And then you're able to oscillate back up to this really much broader view. We need to drop a link to RFD 63 in here. But in terms of so at the same time, you're kind of like in the kind of the deepest possible muck in the lowest levels of the system in terms of early boot. You're also like at the whiteboard in terms of conceiving of what the kind of the networking interfaces we want to have for customers and the way we kind of think of that problem. Could you speak to that a little bit? Because just that ability to oscillate, I just feel is extraordinary, and it's been such an asset, I think, to your teammates so many times over.
Sure, I can try. I think there's a lot of stuff that's just virtue of being at the company early. There wasn't really a lot of other folks to do stuff.
Yes.
So there is a lot of stuff where it's just like, hey, how do we start thinking about this? And I think for me, one of the things that's there is that you'll see in that actually RFD 63 was like the last of a set of networking docs, and really started from higher level product comparison, kind of feature use cases, user networking API that we wanted in another doc, and then with that in mind, how do we start building up the lower level stuff?
I know we go to this metaphor a lot, Adam, but I'm sorry. These are the Federalist Papers for Oxide. These RFPs, these early RFPs from Robert.
But I think a lot of it comes back to, for some of these things, they're things I've been thinking about for a while, so that helps. Even though RFP 63 there's a lot of retrospective and on past attempts there, or goals, or things that worked well, things that didn't work well, what we learned from paper reading and other stuff. And I think coming back to the if you go back to that dog patch deck in 2014, there's a lot of the high level goals, and I'd say experience and kind of usability goals, are still kind of are things that are kind of always in the back of my head. So I think that's always helped to kind of anchor that, or kind of raise questions about what does this feature look like, what does it mean, how does it actually tie back to those goals that we have. And then I think sometimes for me, sorry, go for it.
No, go ahead. No, sorry, go ahead.
I think sometimes you need to work, being able to get, well, maybe it's a little bit of thrashing. And sometimes you need to kind of really focus on one or the other. It helps to kind of, for me at least, to go to different things, because sometimes some of these small bugs are kind of low level details. You can kind of really just focus in on it, but having the broader context of how that fits into the system is helpful, or a good distraction from that. So I don't know. It's not really a good answer.
Definitely. Yeah, I mean, no, that's a great answer, and I think it's. It is really. I have always believed. I mean, Adam, you too. I mean, this is like a unifying belief, I would say, across the company, is that details really, really matter, and that if you want to understand things at the highest level of a system and understand how these big pieces go together, you really need to understand low level details in order to be, because if you don't, that's where you get these kind of emergent behavior that really it runs contrary to the goals you have as a system. So I think it's really, really important. But I mean, your ability to do it, Robert, has just been extraordinary. I think that I want to ask you about, because as you say, like, okay, it's early, so you're putting together the kind of, as our John Jay, you're putting together the Federalist Papers of Oxide. But we are then adding people to the company that are able to go pick up pieces of that. And, you've always been, I think, terrific about really enabling other people to go pick up these pieces. I don't think anyone has ever felt like, oh God, I can't touch networking because, I can't touch this aspect of the system, because you're always like, no, please, someone, please come on in. Like, water's warm. Would love to help you, ramp you up, and help you understand what I understand, so you can go tackle this. Can you speak to that a little bit as well? Because I think that's part of what has enabled you to be so effective.
Yeah, I mean, I think you're right. I think there's a lot to be said that, I think an important thing is that as you go from, the first couple of us that hire to 10 to 20 to 30, and you continue to grow, is how do you help teach other people what's going on? And how do you help ramp them up? Because I think that's equally important, because, yeah, I mean, the amount that one person can do is bounded. And sure, you can, work overtime, or, push yourself a bit, but that will never be as effective as actually, getting more people together. So I think that to me is kind of a important question of how do you help teach people? How do you help them learn? How do you try to be helpful and help, let folks be productive, and share knowledge? Because otherwise, I don't know. So I think that
we got into this. We got into this in the RFD episode that you joined us for. But obviously, you are our most prolific RFD author, and I think it's been great for people to kind of be able to join the company, or actually, also I'm sure you've had this too, Adam, where like people who have not yet joined the company, like Robert, you're famous to people who have not yet joined the company, because you're just like, I've read this guy's work, I want to meet this person. Like, this is, I feel like I know their voice.
But I think that's, having the docs is good, but it's necessary, but not sufficient for that. Because I think,
right.
I don't want to just show up and just be like, hey, here you go, please read this, 100,000 word dissertation, or 200,000 words, and come up with a summary and go from there. Because I think that's that can be very overwhelming. The same way, this wasn't all written, Rome wasn't built in a day. This wasn't all written in a day. So I think it's important to also figure out, how do you kind of introduce these topics, kind of, get to more and more detail. And then I think a lot of it is also just not being really willing to, if people ask for, hey, how does this work? Being willing to put together an ad hoc presentation, whether it's formally with slides or not, on how does this, what's going on. This is another example that is, colleague was asking about, hey, I'm trying to get more into some of the PCIe hot plug stuff. Like, can you help me understand how this actually all fits together with this? Because, the PCI spec is long and involved, and not, the easiest thing to read. So, then the answer to that is, let's find a time that does this and, get into it. And I think that's partly how you do that. And then helping make sure folks feel that it's okay to ask those questions too is equally important, which, is always an ongoing effort. To kind of build those reports, because you can't necessarily know someone's struggling. So all you can do is try to be open and willing to answer stuff and try to be helpful.
Right. Yeah. And I think, I mean, just getting into PCIe, because I mean, it's another total, someone in the chat, PCIe is a blog. Yes. Now we can, oh yes. I mean, another, and because it feels like, this is true for all of these domains where it is an entire universe of complexity. And I mean, having, kind of helping people navigate it. And then I've always felt that, like, you're so charitable with your own knowledge. It definitely, I feel anyway, that you inspire people to be like, oh yeah, I can learn this stuff too. Like this stuff is actually learnable. This is, it feels like it's very dense and I don't understand it yet, but I just need to, I can do it. I can actually learn this stuff, which is very inspiring because there's a lot to go learn. Do you want to talk a little bit about like just as a very concrete example? I'm not sure if you want to take this recent T6 problem and or this recent LRDIM problem and or both as a kind of another. Actually, no. Before we do that, actually, yeah. So go ahead.
No, keep going.
Actually, let me back up because I have a different question I want to ask you. Then we'll get to those. Because one of the things that I definitely appreciate about, again, the way you think about the system is, and I know other people have appreciated as well, is your ability to seemingly see around corners. And the number of times I will like hit an issue and then I go into an old RFD of yours where it's like, oh my, like, I like look under my chair and like, oh my God, Robert has already written a dissertation on this exact issue that I've grappled with and that I even read at the time, but didn't really appreciate. How do you, I mean, because I feel it's like a real, it's a tremendous gift, for lack of a better word, to be able to kind of project a system into the future and anticipate some of the issues that we're going to hit on a system that's not yet built. Do you have any tricks for doing that? I mean, how do you do it?
I wish I could claim omnipotence or something like that, but that clearly, something like that.
It would make a lot of sense though if you did. I mean, maybe now might be the time.
Yeah, I mean, I think that's a good question. I think a chunk of this I picked up from just working with Keith over the years.
Keith's also very, very good at it.
There's a lot there, but I think this sometimes gets back to so the earlier kind of code review is really trying to ask why. And really trying to understand, how does this fit into the system, or how is someone going to do this? Or if someone wants to do X, what else does that mean they need to be able to do? Or how does it work? For some of this stuff that we're seeing around, I think some of it's cheating that, we've been thinking about for over a decade. Dog patch is 2014, that's 2025.
Yeah.
So someone's just had a long time to just marinate in the back of the head. With just different experiences. And I think part of that also is just a bit of just, paying attention to how are folks using things? How are operators using things? I don't know. I wish I had a better answer for you there. So I could.
No.
Myself. I think a lot of it's just trying to listen. A lot of it's listening. And then a lot of just digging and really needing to understand the low level details before you can kind of go and make the high level answer and how the two inform one another.
I also think that like this is where the amount of time you spend in the details just really helps inform just your engineering wisdom. I mean, just to give you a really concrete example of your wisdom and how he benefited from recently, we had a Murata PowerShelf issue that Eric Austin and our team had done a terrific job debugging. And Eric is like, I think this is a control loop issue, and I think we're going to get a firmware drop from Murata that fixes this. And I remember thinking like, wow, that is, I mean, in some ways that'd be great. But this was a problem that we definitely needed to resolve. Murata did a great job, resolved it. And fortunately we had a mechanism that we had not built anything on top of. We had not built any of the software, but the actual PowerShelf itself had a mechanism to update its software. And that's something that you really believed in strongly when we were looking at PowerShelf selection. I just think it's an example of what I mean of like where not just evaluating kind of the artifact you have in front of you, but like what could potentially go wrong with this, where we would need to be able to update the firmware on a PSU. That is not, it's not necessarily something that the first thing that a lot of people would think about. And you kind of have to have a certain kind of quantity of scar tissue to really be able to think about it. And for many years, we didn't need it. For many years, it would have felt like, well, I don't know, maybe this firmware always does work. But now, of course, we do need it. But we were able to build on top of it, and it's all worked, and we were able to upgrade the firmware. It was terrific. But it was a great example of you really saw around a very important corner.
Yeah, and I think that often just comes back to some, let's say, just scar tissue and experience, right? Some of it was we've had times where we couldn't upgrade firmware, or we couldn't get, we didn't have the tools to, or even get firmware updates. And so we've just been burnt by that over the years. And so I do think there's also just, if you really want to think about how you approach and think about firmware, and just just the same way it's like software, and just that it's not this. While it can be very hard to understand, just because of the specifics of the way you're working with vendors, obviously, if you just get a binary blob, it's hard to really get into there. But it's a thing that can fail and needs to be updated, just like anything else. So I suspect that if we probably go back to Dogpatch, we probably have some commentary on the firmware that we were dealing with, and just the operational problems there, and trying to figure out how do you get to a better model. Where even is all the firmware? If it's there, assume something's going to go wrong. Or if there's an EEPROM that has data, assume it has to be flash. We're going to need to flash it, and then once you start thinking about it in some portions, then it turns out that that's actually true in a lot more stuff. There's nothing that's just specific to. I think a lot of it is also just trying to take what are the things that you learn from one area, and don't just how can you apply them to others. And sometimes that'll be right, and sometimes that'll misfire, and maybe not be quite the right starting approach. But I think it lets you kind of ask other questions and helps you kind of think about that. So, for some of us, it's like no one would say, we should never be able to upgrade the software in the product.
Right.
The same would kind of be true. It's like, well, if the only way someone comes back to, what's the service experience? Okay, let's say we did have to do this. If there was no way to do online, to upgrade the firmware of the rectifier through software, then that means I'd have to send a tech out to every DC of every customer, and they have to pull one out one at a time and do this. And that's just not, that works when your N is small, and it's, a bad day for someone, but it really doesn't scale. So that's another big part of just, where are these things that are, what would be the remediation if it fails?
Just asking yourself that question for all these, because as a result, like we did, the fact that we did our own PowerShelf controller, which is not necessarily the first thing that I think other people would think about. It's like, and Murata, to their credit, I would say Murata, some other PowerShelf manufacturers had different opinions about us doing that. And it was a real tribute. Part of the reason that we have a great relationship with Murata is because they were willing to accommodate the fact that we're like, no, we're chucking out your PowerShelf controller. We want to do our own. And that was a very, very, very good decision, because it gave us control over, and not just the ability to update the firmware, although also that too now, but the level of observability into a part of the system that doesn't generally get that kind of observability.
Yeah, and I think what helped is, again, from the kind of RFDs or docs building up on top of one of another. I think it's something like RFD 82, which is the one about kind of operator design principles and facilities for operation, has something about firmware upgrade in it. So then as you're going out and kind of sending these questions out to different vendors, you can go back and say, okay, what are the things I need to think about from there? What are the kind of the key things? How does it apply to things, even just not just firmware, but when a rectifier, we'll just pick on the PowerShell, fails, how to identify which slot it is, what serial number it was, where is it, and how does that turn back into, just different features that you need, and how do you tie that into basically different operator stories? And then, that same thing is true of failing disks, right? I think it's much easier for us to think about, a disk fails, I need to pull it, I want to blink the right slot. Well, the same is going to be true of a rectifier. The same is going to be true of a fan. The same is true of, a transceiver. So, there's a lot more similarity in some of these things, even though there are differences.
Yeah, so I'm going to try to make RFD82 public while we're in the podcast. So RFD82 is not currently public, but I think it's a very good one to make public, because that really it captures, I think, an important aspect of your own approach, and you're thinking about the way we ask different questions of different parts of the system.
Yeah.
Check you, Steve. Yeah.
As I say, and this isn't also, there was a lot of different folks provided feedback on there, and there's a lot of different work there. So it's not, again, this is another one of those things that's not just, a single person doing it. There's, we're taking these ideas, urging colleagues to kind of get feedback on them, explore it more, get different perspectives. Make sure we're communicating it well. That makes it better. So it's not,
I think I've just made 82 public. so
even if I'm just the author,
I made something public. Exactly. Definitely made something public. So let's hope it's RFD82. So you may or may not. It may take a second for this is terrific RFD API. So that may take a second, but hopefully people will be able to see that at some point real soon. Okay, so and I think Robert 82 is a great one in terms of your own kind of disposition. So maybe to kind of just dive back down into some of these specific technical details of things that you've been dealing with recently, because I mean, the T6 issue is a really interesting issue. I'm not sure if you're willing to get into the weeds on that one, but sure. I do think that is a very, very concrete and how much do you know about this one, Adam? Have you?
Only Robert was describing a bit of it to me maybe a week or two ago, as I heard a lot of T6 buzz. But for T6 is the NIC silicon that we're using in the next generation server, right?
Current.
In the current generation.
Current generation, pardon me.
Yeah. So this is in Gimlet.
Yeah, so we do something a little weird with the NIC. So there's something
in stark contrast with the rest of the system, where we are just like
down the fairway. Normal.
Down the fairway, exactly. It's like we also are a little weird with the NIC. So welcome to Oxide.
So
we've gone our own way.
One of the things that we were really trying to make sure we could do, because the NIC has its own firmware and configuration, which changes a whole bunch of different settings and things there, is we wanted to make sure we could validate/attest that information. And we went through a bunch of different ways as a group to figure out, how could we do that? And what we settled was that the NIC actually has its own manufacturing mode built in. So, which is useful, because some of this config file are things like, what PCI, it's a whole bunch of information for the PCIe SerDes, or, describes things about how Ethernet should work. What do you have I2C for transceivers? Do you have different PHYs, etc.? So this information is all very critical for the NIC to work, but we didn't want to have just a one-time factory programming process here, because what if we need to update it? What if something got wrong? How do we deal with it? So we end up using this feature of the NIC called manufacturing mode, which basically has the NIC boot out of an internal mask ROM. It doesn't enable Ethernet. It doesn't load any firmware that would run on some of the cores internally. It doesn't do a whole lot of stuff, but it gives us access to the hardware blocks for the NIC's own EEPROM and SPI flash. So basically, what this means is rather than basically creating a complex MUX system to change ownership of these devices, like we have to for the host SPY flash, here we basically read and validate this through the NIC in its manufacturing mode. So what this means is that every time the server turns on,
booted. Importantly, like this means we're able to do this. We don't. This is not the SP running in some context before the host CPU is up. This is the host CPU is able to do this while it itself is up.
So the way we've rigged this up is that on the board we have a GPIO strapped. So the system, the NIC always shows up in manufacturing mode. Then, because we have power control over every device, we can basically validate all this. And effectively, we don't necessarily turn off all the power here. We kind of reassert the reset of the device and then basically boot it back up into what they call mission mode.
And so the way that normal folks would program their NIC is like having a little like a NOR flash or whatever kind of strapped to it that had this configuration information and it loaded up autonomously. Is that?
The way mission mode works is exactly that way, Adam. They basically have a little SPY NOR flash and a little EEPROM, and it reads from that. And so we have those same things. It's just that in manufacturing mode, to basically bootstrap it, we just do it through the NIC.
Right.
On a normal PCI card, this is just a little jumper that's there for the factory, done once, and then you update this. You can update the firmware from the NIC while it's live, but.
Right. And as you were saying, like doing this every time allows us to put known, attested, valid, bits there, as opposed to having this question of what's living persistently.
Yes.
And did, some nefarious actor manage to wedge some bad bits down there?
It also solves the factory the egg problem. Like, how do you get the initial version on there? It's just like, they're never. It doesn't matter if there ever was something there or not. We just always put what we think should be there.
Right.
Well, gotcha. And this is like having the recovery path be the primary path, Adam. It's like this is so you don't have this kind of path that you like rarely execute that when you needed to execute doesn't work. And it also because this is a real problem with like NICs have gotten really, really complicated. And it's like, oh, by the way, like there's another computer over there. Like, sorry, I mean, it's not really clear like who's in charge of the system anyway. And especially with like, smart NICs, they're being pretty overt about like, no, I've got my own CPU. I've got like I load my own OS image. And it's like, no. We don't want any of that. We want to have all this information flow in a way that it's attestable, that we know exactly what we're putting out there so we don't want that level of autonomy out of the system. We don't want this thing, and for a bunch of reasons, security, reliability, a bunch of things. So, Robert, this felt like a huge win that we can use this manufacturing mode to do this. I mean, a real important aspect. I mean, it kind of reminds me of the fact that we don't actually do warm resets. We only boot because we don't want to have this kind of like state accruing in places. And
it definitely simplified we talk about hardware software co-design. This definitely simplified the electrical design. Definitely the last thing you want are more SPY muxes and other things in the way, dealing with voltage translation,
oh god, yeah,
dealing with questions of which SPY port would we have to connect it to, on what device, what way with data flow. So it really simplified a lot of stuff, which was
actually this is a very good point, Robert, because it's like I do feel that when we I had always thought that like there's kind of this back and forth over what controls a certain aspect of the system, whether it's the SP or the kind of the host CPU. And there's a kind of a Conway's law thing that, you got different orgs that are kind of dueling for power, of course we don't have at Oxide. But like, even if you are like, you have like total organizational harmony, just when you have something that is effectively dual ported, that is kind of owned by two things, you have all of these like electrical issues that are really thorny about, as you say, like level translation, which is a bunch of stuff that we want to, just to underscore the importance of this.
Yeah, we have a team that has gotten it right time and time again, but also, same way people joke, the best software is the code you didn't write. No bugs in the code you didn't write. There's no electrical problems if you don't put those things down. So Sometimes they're necessary, but if you can get away with it, it makes it a lot smoother. So, anyways, all that said, the way that this kind of whole problem is that the mask ROM starts up in PCIe Gen 2. It's basically is hard coded in silicon to start as a Gen 2 by 8 device, as opposed to a Gen 3 by 16. And we had occasionally seen some failures, and I think it was really Josh Glula who insisted we kind of do some of this boot loop testing where we'd occasionally see devices that had a surprisingly occasional failure to train the device in manufacturing mode. And if we came back to it later and tried to restart things or took another lap, it would often work. Or even if you tried to reset it after that, it would come up just fine. But first time on a cold boot, it wouldn't turn on.
And so when you say it does not train, what does training a link mean? Who's doing that training, and what does it mean when it fails to train?
Yeah, so that's a great question. So what we think of this is, so there's a complex state machine in the PCI docs. So basically, a PCI device goes through to basically have a PCIe link come up. So when your operating system wants to go read or write from a register, that ultimately gets transformed into a transaction on the PCIe bus, which is a point-to-point link between a port on the CPU and the downstream device. So like the NIC in our case. You may have switches or other things, in more complex designs, but really you can think of PCIe as a bunch of point-to-point links, generally between something on your CPU, which they may call the root port or an upstream port, and a device, often called the downstream port. And so link training is a process of basically figuring out, shared, effectively, what are the shared ways we're going to operate. So, for example, because PCIe is backwards compatible, you can take, today's Gen 5 devices and put them in a PCIe Gen 1 board, and the link will train at PCIe Gen 1. You might have a root port that supports up to 16 lanes, but you might put in a NIC that only has one lane, small 1 gig link. So it will do that. To make these links work at high speeds is a very complex process because you have to figure out a lot of equalization and tuning so that they can interact. Effectively, link training is this process in this kind of large state machine that basically, hopefully, ends with the link training, so basically successfully completing the state machine. And it's really done by the PCIe device that you're plugging in, and really the PCIe root port, which is generally a whole bunch of hardware in your CPU that probably itself has a secret core running stuff too that no one tells us about. So
is this about figuring out analog kind of coefficients and constant values that make things flow with minimal errors?
Yeah, I think that's one part of it, and that's definitely a large part of it, and other parts of like the digital protocol communication.
Gotcha.
What features can be used. So, the PCI SIG has done a lot of work, and it's a testament that we can. PCIe has been backwards compatible back to its first release.
It's amazing. Yeah. So that is what it means to train. So when we're not training occasionally in manufacturing mode, we're just giving up on this. Like this device is just not working. I don't know why.
Yeah. Basically we don't see a device come up. So there's a register in the root port that says, is there a PCI link established? And if you read it, it says no.
There sure isn't.
There sure isn't. And you're like, well, that's very sad. So there was a whole bunch of stuff that we were trying to do to figure this out because, we had some challenges in the T6 initially. There was some erratum we found the hard way around,
yes,
it needing some double resets and some other conditions. So
double purged.
There's a lot of investigation that we kind of split up and kind of took this in a couple different phases. Especially as I think right as this was kind of kicking off, I was disappearing on vacation for a bit. But I worked with Nathaniel and Josh, and Nathaniel started to basically go through a bunch of, just different questions we had electrically. Is there a chance that this could be happening because we don't see the device coming out of reset? So one of the first things we kind of looked at, and Nathaniel can correct me where I'm misremembering some of this, was trying to bifurcate, did the device assert it coming out of reset, and did we ever try to even begin PCIe initialization or not? Because depending on the answer to that would take us down two very different paths. And the chip itself has a little pin that says it came out of reset. So there's a bunch of stuff we looked at there, and secondarily, because of a whole bunch of the low-level work we had done to boot, we knew how to read out the state of the PCI state machine diagram that the root port thought it was in. So what this meant is that we could go look at the root port. It has, basically a ring buffer of the last 30-ish state transitions it's performed. So we can figure out what has it been doing? What has it seen? As kind of a guide, and you can compare that against the PCIe spec, and there's more or less a one-to-one correspondence between those states and the state machine.
And how are we able to query that because of our own holistic boot? Because who's got access to that?
So
that
you could actually anyone who has access to the system management network. So it doesn't, strictly speaking, need to have holistic boot. Asterisks.
Right.
Sorry. So anyone can read this. That is, whether you're, in holistic boot or on the Oxide architecture or just running a Lumos in general, on Linux or other systems, you can actually read from the system management network. Now, knowing what to read and what maps to what can be a little more challenging, because the big gotcha, as we said earlier, is that the CPU is flexible. So it has 128 lanes.
Right.
And there's a mapping, when you talk to that firmware, between some of those lanes and what underlying hardware resource they're using.
I mean, sounds, Robert, like you're saying that anyone can read it, but holistic boot allows us to read it coherently and know what the fuck is going on. Whereas in other scenarios, it's possible, but kind of academic, right?
They're very hard to make sense of it. Yeah.
You can, with enough expertise, you can build up a mapping. It's just certainly a lot faster when we have a data structure that tells us this is what it is for this. This device, which should have the T6, read all these registers, is certainly a lot simpler, and certainly a lot easier, because we also integrated a bunch of register grabbing initially into the actual boot and training path itself. So we could actually just, on a debug build, for example, we'll just automatically collect a whole bunch of different registers from the PCIe core and the PCIe port, which corresponds to the root port, just by default. And so certainly that is where this is a lot easier, because that's not as straightforward to do outside of building it really into the system itself.
Yeah, totally. So you were able to go through that to figure out why is this thing not training?
Well, yeah. So that we were able to eventually kind of first do that first kind of bifurcation and say, okay, the device is always coming out of reset. Then we can go through and figure out, why. Because basically, we no longer have to go look at we had a lot of electrical questions, but that ruled out a whole huge class, and I'm guessing Nathaniel was thankful was back in my court a little bit.
Yes.
But yeah, so then we started looking at this, and we had this boot loop stuff that Josh had put together, and we had a modified version that was grabbing out some of this register state at every loop. And actually, Andy had actually already gone through and analyzed a bunch of it prior to me coming back to this problem when I was coming back from being out for a little bit. So once we kind of had the sense of that these were all here, these were all very similar, and they were all ending in a similar state, it got us, it was pretty suspicious because what we actually saw, and so to understand how PCIe works, you always train a PCIe device to Gen 1, no matter what. And then from there, you're going to go to different speeds. And basically, as part of the Gen 1 negotiation, you're saying what else you can support. And then the device will go and go to these higher speeds. 2 versus 3 is very different, and then 3, 4, 5 are kind of a different path. But we'd see that we basically got to Gen 2. We just successfully trained to Gen 1. We would go down the upgrade path to Gen 2. We would think, we got to Gen 2. And then, as you're kind of going through the state machine and you're waiting for the other side to acknowledge all of this in the recovery.speed substate or something like that, it'd just be like, well, we timed out. And we're going back to detect, which is basically the entry state that says, start looking for
nothing
something.
Here. Yeah, womp.
Well, actually, it wasn't quite nothing here. But, the whole point is basically you go back to detect to try to see, which is basically see, is anyone there? We would see someone is there and start going down the path again, anew. You kind of do a whole fresh link training. And it would just stop replying at a certain transition point that was an indication to enter what's called compliance mode. So normally compliance mode is something you only enter because you explicitly request it because you're at one of these PCIe interop tests and you're trying to prove something to you and the PCI, basically to pass compliance, PCI level compliance.
Mom is here right now, so we need to. I'm setting the mom is here bit. We need to actually do something slightly differently.
But normally you're not supposed to enter it by yourself. There's only very few occasions that enter it of its own volition. So we would just find that we were entering it, and that was just kind of confusing. Especially because we had the ability to see what the host side saw, but it was not very easy to go. There's no good way to go answer what was the T6 seeing, and getting a logic analyzer on that was going to be very challenging because we needed to get that on there. We need to get it on for all 16 lanes, and that's the one downside with the chip down solution is that it's a little bit harder to get the logic analyzer on there.
Just a little bit.
So then, we started doing different experiments. I don't remember all the ones I did, but the one that surprisingly worked was, we kind of said, hey, everything's training to Gen 1 just fine. And then it's going to Gen 2 that's failing. So what if we just stopped at Gen 1?
Yeah.
Especially since we're only in this manufacturing mode for a little bit. And when we
actually don't care about the throughput in this manufacturing mode where we're just
the difference between Gen 1 and Gen 2 is not going to, we're really bound by the time it takes for it to talk over SPI more than anything else.
Right.
The actual PCIe bandwidth is not going to make or break us. So, shockingly enough, that actually worked, which is both great and a little dissatisfying, but
dissatisfying that we don't know what's going on. But I think we also learned in this that, as it turns out, this mode, we think this makes a lot of sense to use this manufacturing mode, even though on every boot. But it may make it's a little more unusual from Chelsea's perspective, and
for them, it's a factory only tool. So any issues that they would have had there, it's really just factory programming. If you end up needing to just hit the thing twice, and it doesn't impact normal operation, that's totally fine in a factory context. Not fine in a product context. So for us, but
this was hugely important because these were, when we in our testing in manufacturing, when these things were failing to come into manufacturing mode, we effectively would not ship that sled because we didn't know what the issue was, and we didn't know. I know Nathaniel was, I'm sure, very relieved to get it back into the software domain because kind of the nightmare is you've got a manufacturing defect effectively. where it's like, yeah, that board needs to be scrapped. And that was not the case, which is a huge relief.
Yeah. And and I think, this is another one where, we ended up there, but we definitely didn't start with just software only. And so it's really about, working together, brainstorming different ideas and trying to think about, what could be going wrong. And then more so, how do you make hypotheses that you can disprove one way or the other to help kind of narrow the solution space? Because otherwise, Joker's wild on different things we thought about. And there was a bunch of other electrical stuff that we did investigate around, were we seeing power, were we not ramping power correctly? Other things, could there be something where we're not draining enough while we're taking this A2 lap? And some of that were easy experiments to go run. So we did do some of them just to disprove that. And, just the, negative results actually are important, which is...
Yeah. Well, this is a very important point you're making, Robert, in terms of like holistic design also means holistic debugging. And you've got to get, when the system is not behaving correctly, you've got to get ready to cross a bunch of different boundaries that are historically difficult boundaries to cross. And you've got to be able to really get a team together from across the stack to go brainstorm an issue.
Not to quibble, Brian, but I'd say it enables holistic debugging because as you're saying, like holistic design. If this were a more traditional system, you'd chase it to the border, and that's the best you could do, right? Like you could sort of imply that there was some other component that required now examination, but there was really no trivial way or straightforward way at all to communicate across those arbitrary boundaries. In fact, that Conway's law, I don't know what Conway's law is when it applies to an entire industry, but you've got that industrial super form of Conway's law applied to this aggregation that has become the modern server.
Is that like a Conway's wall? Conway's...
Yeah.
Mr. Conway, tear down this wall.
Yeah, and I think that's actually a good point, because in this, we talked about the software changes in the host, but we also looked at stuff in the service processor ring buffers, FPGA register readbacks. We added and captured a bit more state along the way. And the fact that we could kind of use that to rule out things. The fact that we could easily see what is the state of this ext reset L pin is hugely helpful. Or the fact that, if we had to do something much more invasive, we could have communicated to the service processor over that communication channel.
Right. I mean, I think having all those kind of options at our disposal really does allow us to, as you say, Robert, it gives us the opportunity to go holistically debug. So,
right.
That is awesome.
And I think that is actually, the ultimate part of Dogpatch, taking it back there, is these different things actually working together towards solving our problems versus, fighting with one another and kind of hoarding information. And, because we're doing all sides together, some of the things in Dogpatch that we're saying, it can only be the OS. Well, that's actually a reflection of the fact that, that's because that was the only thing we could actually modify. And the fact that you can modify not just the service processor, not just the host software, but actually the board design itself gives us a lot of different flexibility in how we can approach different problems.
That's right. And actually, RFD88 is actually already public, which is great. So that one I don't need to make public because it's already public, but that's another one to check out, which is an RFD that talks about exactly kind of how we think about who does what in the system. And definitely a consequence of this, this kind of holistic thinking. Robert, I think this has been a very exciting way to kick off Robert Mustacchi Appreciation Week.
Let's nip that one in the bud.
But we really, really, really appreciate it. It's so great to kind of obviously walk through the origins of Food for Money Friday. I mean, clearly, let's not lose track of what's important here. Yeah, let's not bury the lead here, but. Future historians will be very pleased that they have finally discovered on the canonical origins of this cultural phenomenon known as Food for Money Friday. But the just getting kind of your perspective and kind of the way you've done what you've been able to do, which is with a lot of collaboration, a lot of hard work, and being willing to dive into new things all the time, and then also being able to come up and think about, how does this impact the actual user of the system? And I love your thinking about that kind of operator empathy as a guide in terms of a lot of what you've thought about in terms of the system. But really terrific. So thank you very much for joining, for indulging us, and for taking us up, down, and all around.
No problem. Thanks for having me. It was my pleasure.
Well, good stuff. And then Adam, next week, we've got a European friendly time, I understand.
That's right. Yep. 9 a.m. In a week, 9 a.m. Pacific. And we've got Orhun, and we're talking about Ratatouille, one of our favorite crates. I know we talked about lots of favorite crates last week, but one of our favorite crates for writing Tuies. It's going to be really fun.
It's going to be a lot of fun. So join us next time. And looking forward to having you. And Robert, thanks again for joining us. That was a great discussion. All right. Thanks, everyone.